Dear students, in this video you are going to learn about the second part of induction, that is mutual induction. So what is mutual induction? See the name itself, mutual. So mutual induction is the phenomenon of inducing EMF in the secondary coil due to change in current in the primary coil and hence the change in magnetic flux in the secondary coil. So here mutual induction means there will be two coils. One is called as primary, another one is called as secondary. So whenever the current in the primary coil is going to change, it will produce change in magnetic field around it, which is linked with respect to the secondary coil. In turn, the magnetic field linked with the secondary coil changes, the flux linked with the secondary coil changes, inducing EMF. This phenomenon of inducing EMF in another coil with respect to change in current in the primary coil is called mutual induction. Mutual inductance. Now, as we know that the flux is directly proportional to current, which we have learned in induction. So flux is equal to M into I. Now here you can see that phi 21 is nothing but flux linked in the secondary coil with respect to primary coil. That means current is produced in the primary coil, that is I1 is the current passed in the primary coil, and the flux linked in the secondary coil is phi 21. So flux in the secondary coil with respect to primary coil is equal to M into I1, where M is called proportionality constant named as mutual inductance or coefficient of mutual induction. If the current passing through the primary coil is equal to 1 ampere, the mutual inductance is equal to phi. So we can define the mutual inductance as the magnetic flux linked with the secondary coil when unit current passes through the primary coil. Also, we know that EMF is equal to minus d phi by dt. Now here EMF is induced in the secondary coil. So E2 is equal to minus d phi 21 by dt. Now in place of phi 21, if you're going to substitute the value of M into I1, you're going to have expression as E2 is equal to minus M di1 by dt. If di1 by dt is equal to 1, then M is equal to E. Again, we can define the mutual inductance as the induced EMF set up in the secondary coil when the rate of change of current in the primary coil is unity. Now here di by dt is nothing but rate of change of current. So when it is equal to 1, then mutual inductance is nothing but the EMF itself. SI unit of mutual inductance is Henry, which is represented by capital H, which is a scientist name. Mutual inductance is said to be 1 Henry when 1 ampere current in the primary coil links magnetic flux of 1 Weber across the secondary coil, or it is said to be 1 Henry when unit rate of change of current in primary coil induces the EMF of 1 volt in the secondary coil. Again, induction is a phenomena, inductance is a constant, proportionality constant. Mutual inductance of two long coaxial solenoid. That means we are going to give the expression for mutual inductance, that is M. So here I am going to consider two coils. One is P. P stands for primary coil, and that is secondary coil. Coaxial. Coaxial means both the coils will have same axis. Coaxial. Same axis is nothing but coaxial. Now, if you see, the secondary coil is connected with respect to a galvanometer. Let L be the length of the solenoid, A be the area of cross section of the solenoid, and I1 is the amount of current passing through the primary coil. So whenever the current passes through the primary coil, magnetic field produced by the primary solenoid is B1 is equal to mu naught N1 I1, which we have learned in the solenoid. The magnetic flux linked across one turn of the secondary solenoid is phi to 1 per turn is equal to B1 into A, because phi is nothing but B into A. Now here B1 means the magnetic field produced of the primary coil, which is linked with the secondary coil. So B1 into A, which is equal to mu naught N1 I1 A, which is equal to mu naught capital N1 I1 A by L, where small n is nothing but number of turns per unit length. So here capital N represents number of turns. Now the magnetic flux linked across n number of turns of the secondary solenoid is phi to 1 is equal to mu naught N1 N2 I1 A by L, where N1 is the number of turns of the primary coil, N2 is the number of turns of the secondary coil. But according to the definition of inductance, phi to 1 is equal to M21 I1. So if you're going to equate them, what you're going to have, M21 is equal to mu naught N1 N2 A by L, or simply we can say mu naught N1 N2 A into L. Similarly, if you pass the current through the secondary coil and the EMF is produced by the primary coil, so that mutual inductance M12 is nothing but, again we will get the same expression, mu naught N1 N2 A by L, which is equal to mu naught small n1 small n2 A into L. For two long coaxial solenoid of same length and cross-sectional area, the mutual inductance is same and leads to principle of reciprocity. That means if you pass current through secondary coil, you can induce EMF in the primary coil, just like how when current passes through primary coil, we induce EMF in the secondary coil. So M is equal to M12 is equal to M21. Additional information. If the two solenoids are wound on a magnetic core of relative permeability mu r, then M equal to mu naught mu r N1 N2 A by L. If the solenoids S1 and S2 have number of turns N1 and N2 of different radii, that means the radius of the first solenoid is different with respect to the radius of the second solenoid. So let's suppose that the radius of the first solenoid is R1 and the radius of the second solenoid is R2. Now if you see, R1 is less than R2, that means the radius of the secondary coil is more when compared to the primary coil. Then the mutual induction, the mutual inductance is represented as mu naught mu r N1 N2 into pi R1 square by L. Mutual inductance depends also on the relative placement of the solenoids. Coefficient of coupling, which is represented by K, between the two coils having self-inductance L1 and L2 and the mutual inductance M is. Now here comes a question. Whenever the current is passed through the primary coil, the magnetic field is linked not only with respect to the secondary coil, but it is also linked with the primary coil. So inductance is produced or EMF is produced not only by primary but also by the secondary. So if you want to find the total EMF, we have to combine both self-inductance as well as mutual inductance. So if you see K equal to M by root over L1 L2. Now here there is no proof for this because in our syllabus there is no proof. It is for your information. Generally, the coefficient of coupling is always less than 1. If L1 and L2 are in series, then L is equal to L1 plus L2. If L1 and L2 are in parallel, then 1 by L is equal to 1 by L1 plus 1 by L2, just like resistors in series and parallel.